These examples go as section 8.2, Systems of Linear Equations in 3 Variables and Applications. Example 1. Determine if the ordered triple is a solution to the system. Okay, in order for it to be a solution, the ordered triple here has to work in all 3 of the equations. Alright, so what we're going to do is we're going to fill in this first number for x, this second number for y, and this third number for z, and we're going to fill it into each of the equations until all of them work or we find one of them that does not work. Alright, we got 5 times -2 minus -6 plus 3 times 3, and we would like for this to be equal to -7. Alright, 5 times 2 is -10. The opposite of -6 is +6, and then 3 times 3 is going to give us 9. Alright, let's see, -10 plus 6, that's going to give me -4, and -4 plus 9 is going to give me 5, and 5 is not equal to -7. Therefore, this first one is not going to be a solution to this system because it didn't work in the first one. Doesn't matter if it works in the second and the third one. If it didn't work in the first, it's not going to be a solution for the system. Alright, let's try B. We'll plug this number in for x, and this one in for y, and this one in for z. Now remember, we have to plug it into all 3 of the equations here and make sure it works. We have 5 times -1 minus 2 plus 3 times 0, and we want that to be equal to -7. I have -5 minus 2 plus 0, and I know that -5 minus 2 is -7, and -7 plus 0 is going to give me -7, and they are the same thing. So it works in equation 1. Let's try it in equation 2. We have 3 times -1 plus 4 times +2 minus 0 is equal to 5. 3 times -1 is -3. 4 times 2 is 8. Then minus 0 is going to give me 5. Well, -3 plus 8 is 5, and 5 minus 0 is 5. And 5 is equal to 5. Therefore, it works in equation 2. So we tried in equation 3. 9 times -1 plus 5 times 2 plus 7 times 0 is equal to +1. 9 times -1 is -9. 5 times 2 is going to give us +10. 7 times 0 is going to give us 0. We want all this to be equal to 1. Well, -9 plus 10 is 1, and 1 plus 0 is 1, and 1 is certainly the same thing as 1. Therefore, this ordered triple works in the third one, and we can say that yes, this second order triple is in fact a solution to our system. Example 2, solve the system 2x minus y plus 5z equals -7, x plus 4y minus 2z equals +1, and 3x plus 2y plus z is equal to -7. Alright, let's number each one of these equations. This will be equation 1, this will be equation 2, and this is going to be equation 3. Okay, what we're going to do is we're going to take 2 of these equations and we're going to eliminate one of the variables. Then we're going to take 2 different equations and eliminate that same variable so that I'm left with 2 equations that have just the same 2 variables in it. And then I'm going to either eliminate or substitute to solve for one of those variables. Okay, here's what I mean. Now I am going to eliminate the y's because this y has a sign that's opposite from the other 2. Not only that, but the coefficient on this y is 1, which is very convenient. And so that means I'm going to be able to multiply this equation by something so that it matches the coefficients of the other two. All right, let's consider equation 1 and equation 2 first of all. So I'm going to ignore equation 3. We have 2x minus y plus 5z equal to negative 7, and we have x plus 4y minus 2z equal to 1. Remember, I'm eliminating the y's, so I'm going to have to multiply this first equation by 4 so that I can have a 4y here in the middle that will cancel out with the 4y here on the bottom. This is going to give me 8x minus 4y plus 20z equals negative 28. And now I should be able to add these together. X plus 8x is going to give me 9x. The y's are going to cancel. We wanted that. Negative 2z plus 20z, that's going to give me 18z's. And over here, 1 minus 28 is going to give me 27. All right, I'm going to call this equation 4. And we're going to come back to that in just a minute. Now what I need to do is I need to pick 2 more equations. Now I have to choose equation 3 because I haven't used it yet. And I'm also going to choose equation 1, remember, because I said the coefficient right here was 1. And it will be very easy to turn that into a 2 so that they'll cancel out. All right, so now we're going to be looking at equation 1 and equation 3. So that gives me 2x minus y plus 5z equals negative 7, and 3x plus 2y plus z is going to be equal to negative 7. Now remember, I have to eliminate the y's because I eliminated the y's out of this equation right here, and I want to finish this system with just x's and z's because that's what I had in this one right here. Okay, let's multiply the top equation by 2, because remember, I want to have a 2 right here so that it will cancel out with the y down here underneath. That gives me 4x minus 2y plus 10z equal to negative 14. And now I should be able to add these together and come up with a new equation with no y's, just x's and z's. 3x plus 4x is going to give me 7x. The y's are going to cancel. Z plus 10z is going to give me 11z's. And then negative 7 plus negative 14 is going to give me negative 21. We'll call this equation number 5. Now I'm going to look at equations 4 and 5, where we have 9x plus 18z equal to negative 27, and 7x plus 11z equal to negative 21. And I would like to eliminate either the x's or the z's. Now, these numbers are fairly large, but I do notice in this first equation here, equation 4, that everything can be divided by 9. And 9 is all these are multiples of 9. So I'm going to take my first equation and I'm going to divide it by 9. That's going to give me x plus 2z equal to negative 3. Now what this has done is it's given me a lot smaller numbers down here. Not only that, but it's given me a 1 coefficient right here, and it'll be pretty easy to turn that into this 7 right here. So if this is going to be the second part of my system, let's take this equation now and multiply it by negative 7. That gives me negative 7x minus 14z equals 21. That's going to be a positive 21. And I'm just going to take this equation and write it down here underneath. 7x plus 11z equals negative 21. And now we can add these together. The x's are going to cancel. We wanted that. Negative 14 plus 11 is going to give me negative 3z's. And 21 minus 21 is going to give me 0. So now I have an equation where I can solve for z. Let's divide both sides by negative 3. We find out that z is actually equal to 0. This solution I will take and I will plug it back into either this equation here or this one right here. Because by plugging it into one of those, I'll be able to figure out what x was really equal to. All right, let's plug it into equation 5 here. We have 7x plus 11 times 0, that's the z I just found, equals negative 21. 7x plus 0 is going to be equal to negative 21. Well, 7x plus 0 is just going to give me 7x. And now I can solve for x. If I divide both sides by that 7, we find out that x is equal to negative 3. And now I'm going to take the x that I just found and the z that I just found, and I'm going to plug both of them into any one of the original 3 equations. And I think I'm going to plug them into the top one so that I can figure out what y is equal to. It's not because it's any better or any worse than any of the other ones, just because it happens to be the one that's on top there. Okay, so we have 2 times the x we just found minus y plus 5 times the z we just found. We want this to be equal to negative 7. 2 times 3, this is negative 6 minus y. 5 plus 0, that's just going to give me 5. Sorry, it's 5 times 0. All right, if we add our like terms over here, we have negative y minus 6 equal to negative 7. Let's add that 6 to the other side. We have negative y equal to negative 1. And if we divide that negative 1 out, we find out that y is equal to positive 1. All right, so the solution to my problem, and I should write this out as an ordered triple, and they go in alphabetical order. So our solution is going to be x, which is negative 3, y, which was positive 1, and then z, which is 0. And we really should check that in to the other 2 equations to make sure that it works. But in the interest of time, I'm not going to do that here. So there's our solution, negative 3, positive 1, and 0. Example 3, solve the system A plus 3c is equal to 4, B plus 2c is equal to negative 1, and 2a minus 4b is equal to 14. Okay, first thing I notice is that I do have 3 different variables, and each of my equations here, we have equation 1, equation 2, and equation 3, they all have 2 different pairs of variables in there. Remember, what I'd like to do is come up with 2 equations that have the same variables in them. All right, I think I would like to eliminate the b's because I noticed that the b here has a sign that's opposite from this one up here. So let's consider equations 2 and 3, where I have b plus 2c equal to -1 and 2a minus 4b equal to 14. Since I know I'm going to eliminate the b's, I'm going to multiply this top equation by 4 so that I can get a 4 right here, and my b's will cancel one another out. That's going to give me 4b plus 8c equal to -4. All right, let's add these together. Two a plus 0 here is going to give me 2a's. The b's are going to cancel. We've got plus 8c, and this is going to be equal to 14 minus 4, which is 10. This is equation 4. Now remember, in this case, I'm going to have to use equation 1 because I haven't used it yet, and equation 1 has a's and c's in it, and so does equation 4, the one that we just got from adding equations 2 and 3 together. So that means that I don't have to use equation 1 and eliminate either the a or the c because the b is already gone, and that's what I eliminated to get to equation 4. All right, so my system now is a plus 3c is equal to 4, and 2a plus 8c is equal to 10. What I can do here, by the way, this is equations 1 and 4, is I can eliminate the a's because there's already a 1 right here, and it's pretty easy to turn that into a 2 so that the a's will cancel out. So I'm going to multiply this top equation by -2. This is going to give me -2a minus 6c equal to -8. All right, let's add these together. We know that the a's are going to cancel out. 8 minus 6 is going to leave me with 2 c's, and 10 minus 8 is going to leave me with 2. Let's divide by 2, and we find out that c is equal to 1. Now, I'm going to take that equation, and I have several options. I can plug it in down here, I can plug it in right here, or I can plug it in right here. Now I can't plug it into equation 3 because it has no c's in it. But equation 1, equation 2, and equation 4, they all have c's in them. I think I'm going to choose equation 1 to use though. Alright, we've got a plus 3 times the c we just found. We want this equal to 4. 3 times 1 is 3, so we have a plus 3 equal to 4. And if we subtract 3 from both sides, we find out that a is equal to 1. Now this a, I'm going to need to plug into this bottom equation right here because that's the only one that has a b in it and an a. Or if I want to find b, I can use the second equation here because I have my c. But it wouldn't do me any good to use equation 1 that has just a's and c's, and I know what those values are. And equation 4 has just a's and c's, and I know what those values are. All right, so I'm going to use equation 3. And equation 3 is going to help me figure out what b is equal to. We have 2 times the a we just found minus 4 times b. This is equal to 14. 2 times 1 is 2. We have 2 minus 4b equal to 14. Let's subtract the 2 from the other side. We have -4b equal to 12. And then we can divide this -4 out of here. And we find out that b is equal to -3. When we write our solution, remember we're going to put this in alphabetical order. our solution will be A, which is 1, B, which is -3, and C, which is also 1. And again, we should check these solutions in the other two equations, in equations 2 and 3, but in the interest of time, I'm not going to do that here. So our solution is +1, -3, and +1. Example 4, solve the system x plus y plus 4z equals -1, 3x plus y minus 4z equals 3, and -4x minus y plus 8z is equal to -2. I think for this system, I am going to eliminate the y's. And I know that with the z's, I have different sign here in the middle that's opposite from these two right here, but they also have coefficients of 4 and 8 there. And I noticed that if I decide to eliminate the y's for the same reason, because I know that I have an opposite sign down here from the other two, the coefficients in front of these y's are all 1. And that's going to be a whole lot easier to eliminate. And I probably am going to get to skip one step of the multiplication there. All right, this is equation 1. This is equation 2. This one's equation 3. I'm going to start off using equation 1 and equation 3. We have x plus y plus 4z is equal to -1. And we have -4x minus y plus 8z is equal to -2. And since the y's already have opposite signs and the same coefficient, I can go ahead and add these together. X plus -4x is going to give me -3x. The y's are going to cancel out. 4z plus 8z is going to give me 12z's. And over here, -1 plus -2 is going to give me -3. All right, this is equation number 4. All right, now let's consider equations 2 and 3. And again, I will be eliminating y. We have 3x plus y minus 4z is equal to 3, and -4x minus y plus 8z is equal to -2. Okay, since the y's already have opposite signs and these coefficients are 1, I can go ahead and add these two equations together. 3x minus 4x is going to give me -x. The y's are going to cancel out. -4z plus 8z is going to give me a positive 4z. And then 3 plus -2 is going to give me a 1. This is going to be equation 5. Now we're going to take equations 4 and 5, we're going to put them together, and we are going to eliminate, I think I'm going to eliminate the x, because the first one here already has a coefficient of 1. So we have -x plus 4z equals 1, that's equation 5. -3x plus 12z equals -3, that's equation 4. Since I'm going to eliminate the x's, I'm going to multiply this top one by a -3. The negative, because I want to change that sign to a positive, so these have opposite signs, and then I want a 3 right here so that they'll cancel out. That's going to give me a positive 3x minus 12z equal to -3. Oops, -3. All right, let's add these together. We knew the x's were going to cancel each other out. That's what we wanted. Over here we have 12z minus 12z. They're going to cancel out also. That leaves me with 0 over here. So I don't have any variables. I just have 0. On the other side, -3 plus -3 is going to give me -6. 0 is not the same thing as -6. Therefore, this problem has no solution. Example 5. Solve the system 5y plus z equals 0, negative x plus 4z equals 0, and negative x plus 5y plus 5z equals 0. All right, see, we will call this one equation 1, equation 2, and equation 3. Let's eliminate the x's. Now, equation 1 already has no x's in it, so that means I'm going to be looking at equation 2 and equation 3. Equation 2, negative x plus 4z is equal to 0. Equation 3, negative x plus 5y plus 5z equal to 0. I'm going to eliminate the x's. The coefficients here are already 1, but I'd like to have opposite signs. Let's multiply the top equation by negative 1. That's going to give me x minus 4z equal to 0. And now we're ready to add these together. The x's are going to cancel out. We wanted that. 5y plus 0 is going to give me 5y. Negative 5z minus 4z is going to give me a positive z. And 0 plus 0 is going to give me 0. This is equation number 4. Now I can take equation 1 and equation 4 and try to eliminate one of the variables, either the y or the z. I'll probably eliminate the z. Equation 1, 5y plus z is equal to 0, and equation 4, 5y plus z is equal to 0. Now, if you didn't see that these two equations are exactly the same right away, then what we would do is we could take the first one and multiply it by negative 1. This would give us negative 5y minus z equal to 0, and then we would add these together. And what we would find out is that the y's would cancel out, the z's would cancel out. That would leave me over here with absolutely no variable. There's nothing there but 0. And on the other side, 0 plus 0 is equal to 0. Well, this is true. 0 and 0 are the same thing. This problem has infinitely many solutions. And one way we can write this is we can put it in set builder notation, and it would look like this. We want the set of x, y, and z such that negative x plus 5y plus 5z is equal to 0. That's another way to write the solution set for this system. Example 6. Nicholas mixes 3 solutions of acid with concentrations of 10%, 15%, and 5%. He wants to make a 30-liter mixture that is 12% acid, and he uses 4 times as much of the 15% solution as the 5% solution. How much of each of the 3 solutions must he use? All right, let's organize our thoughts here. And I like to organize mine into a chart. We have an amount, and we are given a percent, and we are looking for a total. The percentages we have are 10%, 15%, and 12%. Oh, and 5%. and 12%. There we go. Now I know I want to have 30 liters of the 12% solution. And I know the total over here is going to be 30 times 12%, which is going to give me 3.6. So 3.6 liters of that 30-liter solution is actually acid. All right, and let's put some names over here. So we got the 10% solution, we got the 15% solution, and we have the 5% solution. Okay, now since we're looking for how much of each of the three solutions must be used, I'm going to put my variables right here in the amounts. And then the total out here is just going to be the product, or the percent, of each amount. So 0.10x, 0.15y, and 0.05z. And my system can be found in this column here. When I add all of these together, x plus y plus z, I'm going to finish with 30 liters of solution. And here, if I take the part of it that's 10% acid and add to it the part that is 15% acid, and add to it the part that is 5% acid, I'm going to get 3.6 liters of total acid in that solution. Okay, now we've been doing systems of 3 equations with 3 variables, and right now I have 2 equations with 3 variables, so I have to have a third one in the system, and that's not going to come out of the chart over here. I'm actually going to have to use my word problem up here, and I'm going to use this part right here that says he uses 4 times as much of the 15% solution as the 5% solution, and I'm going to use that to give me my third equation. The 15% solution is represented by y, and the 5% solution is over here represented by z. And let's see, he uses 4 times as much of the 15% solution as the 5% solution, so there is more of the 15% solution than the 5% solution. My equation 3 here, y is going to be equal to 4 times z. Okay, I've moved over here to a blank slide where I've got a little bit more room to work. And here is the system that we just came up with from our chart. Here's equation 1, equation 2, and equation 3. Now I think to solve this problem, I'm actually going to use a substitution, because this equation right here has 2 variables in it, and one of them has been solved. And so what I'm going to do is I'm going to consider equations 1 and 2. I'm going to substitute 4z in for y. That's going to give me a new equation that just has x's and z's. And then I'm going to look at equations 2 and 3 and substitute 4z in for y. And I'm going to have another equation that has just x's and z's in it. All right, so equation 1 and 2, we have x plus y plus z is equal to 30. And we have y is equal to 4z. All right, remember I'm going to take this, I'm going to plug it in right there. We have x plus 4z plus z is equal to 30. This is going to give me x plus 5z is equal to 30. And here's my equation number 4. Now I'm going to consider equations 2 and 3. Now I'm going to do the same thing. I'm going to substitute. We've got y equal to 4z, and then we have 0.10x plus 0.15y plus 0.05z equal to 3.6. And remember, I'm going to take this, and I'm going to plug it in right there for that y. We have 0.10x plus 0.15 times 4z plus 0.05z equal to 3.6. Let's multiply these together right here. We have 0.10x plus 0.60z plus 0.05z equal to 3.6. And when I add my like terms, we have 0.10x plus 0.65z equal to 3.6. And here is my equation 5. Alright, now what I want to do is I want to take equations 4 and 5, and I want to try and either eliminate or substitute, because I need to get rid of either x or z. Equation 4, x plus 5z is equal to 30. And equation 5, 0.10x plus 0.65z is equal to 3.6. I guess I'm going to eliminate the x's because I already have a 1 coefficient right here. And it's going to be fairly easy to turn it into a 0.10. Let's multiply the top by negative 0.10. Alright, when we distribute it inside, we get negative 0.10x minus 0.50z equals negative 3. Alright, let's add these together. The x's are going to cancel out. We already knew that was going to happen. 0.65 minus 0.50, that's going to give me a positive 0.15z. Over here, 3.6 minus 3 is going to give me a 0.6. If we want to solve this for z, we're going to divide by 0.15. And we are going to find out z is equal to 4. So we need 4 liters of the 5% solution. Alright, now I'm going to take z, and I bet you can guess where I should plug it in so I can figure out another variable. Now I have options. I can plug it in here. I can plug it in here. But I think I'm going to use it in equation 2 here so I can figure out what y is equal to. I think that'll be a little bit quicker. Alright, so y is going to be equal to 4 times the z we just found. Therefore, y is equal to 16. That means we need 16 liters of the 15% solution. And now I'm going to take the z and the y, and I'm going to plug both of them in up here into equation 1. And that should tell me what x is equal to. X plus the y we just found plus the z we found should be equal to 30. Alright, x plus 20 is going to be equal to 30. Let's subtract 20 over to the other side. X is going to be equal to 10. That means that we need 10 liters of the 10% solution. And here is the solution to my system.